Hello guys, welcome back. In this video we'll be learning about an explanation of what we learned in chapter 1 of NCERT class 6th Geography. So the first chapter is Earth in our solar system. Now it says that if we look at the night, what we'll see that not every particle which emits light or which shines is twinkling, right? This is because the light coming from the stars, they suffer refraction. When they suffer refraction because of the changing uh, length or width of the atmosphere, they suffer more refraction as compared to the other, and hence when they suffer more refraction they twinkle more, and hence the stars twinkle, but the planets, the light from the planets, they don't twinkle much. The other important point is that full moon, right, is known as the Purnima, and the new moon is known as Amavasya. I came to know why is it known as Amavasya? What is the etymology of Amavasya? The word Ama means, yeah, it means together. Amavasya means coming together, right? So when does sun, moon and earth they come together such that the earth is in middle of the sun and the moon? We don't see any image of the moon because no light is falling on the moon, right? So hence it's known as on a single longitude, on a single length. They come on the same line, right? They have the same linear, they are on a line, the points are on a line, and hence they come together on a line, and hence Amavasya, right? See the scientific abilities of early Indians, right? And hence this is the new moon, right? One important fact I found that this is very auspicious, and early Indians and even today some Masons, they don't work on the day of Amavasya. The non-working day, the Sunday as a non-working day, has been introduced by the Britishers, right? So yeah, celestial bodies, stars, constellation is the different group of stars, the collection of stars is known as constellation. Now one of the major, most easily, this is important, how if you go to field, how will you recognize or how did the early people, when they didn't had any instrument, GPS, how did they recognize what is the right direction? They used stars, right? The voyages, the ships, the Vasco da Gama, or the people before that, they used ships, they used stars, in order to find the distance, in order to find the directions, right? And north was found using a pole star, right? Now here what you see is a Ursa Major, right? And Ursa Minor is known as the Saptarishi, right? The difference between Ursa Major and Ursa Minor is Ursa Major has a convex handle, the Ursa Minor has a concave handle, right? Here it's written, in the ancient time, people used to determine the direction during the night with the help of the stars. The North Star indicates the north direction. It also indicates the Pole Star. It always remains in the same position in the sky. We can locate the position of the Pole Star with the help of Saptarishi, right? So another important thing, here it is written, right? Some celestial bodies don't have their own heat. Such bodies are called planet. The word planet, right, is very important. The word planet has come from the Greek word planetai, which means wanderers, right? Okay, if you find the Sanskrit word for wanderers, it is plant, right? Plant. So panth, excuse me, panth, Panth, Panth. So the panth and planet, they it seem they seem to be cognates, right? So next is the solar system, 8 planets. Here is the 8 planets: Sun, Mercury, Venus, Earth, Mars. Then there is an asteroid belt: Jupiter, Saturn, Uranus, Neptune, right? A very important points are that the word sun has come from the word solar, and Sol is the Roman mythology sun god. And what I find the similarity, Sol and Surya, they are cognates. And secondly, if you find the image of the soul, it has the horse chariot, and the horse is similar, quite similar to the, if you see the Konark temple, there are also the horses with the sun god in there. Right? And secondly, the word geo or geology, geography, geoid, right? Geographic information system, geometry. The word geo has come from another Greek god, Gaia, right? So the Greek god Gaia, she was the goddess of earth. She was the mother earth, right? And the word writing has come from the graphia, okay? Another, do you know, humans have always been fascinated gazing at the night sky. Those who study the celestial bodies and their movements are called astronomers. Aryabhatta was a famous astronomer of the ancient India. Today, astronomers all over the world are busy exploring the universe. Definitely, Aryabhatta was a great astronomer. Sun, center of the solar system, huge and made of extreme hot gases, 150 kilometers away from the Earth. Figures are not important. If you are preparing for UPSC, it can be important. It may be important, but these days it's not asked. Okay, and next is the Earth. Important point is that slightly flattened at the pole, and that's why its shape is described as geoid, okay, also known as the earth-like shape, right? Then we have moon. Okay, next is asteroid. Between Mars and Jupiter, these celestial objects are asteroid. The important point which I got was that scientists are of view that the asteroids are part of the planet which exploded many years back. This was a very interesting point for me. Okay, meteoroids. The small pieces of rock which move around the sun are called the meteoroids. Sometimes these meteoroids come near the earth and tend to drop on it. During this process, due to friction with the air, they get heated up and burn. It causes a flash of light. Sometimes a meteoroid, without being completely burned, falls on earth and creates a hollow. Okay, meteoroid. right to fall is meteorite. Otherwise, it's meteor if it burns. Okay. Now here, if you see a beautiful image, right? This is known as, in India we call it Akash Ganga, because there is a itihas saying that uh, the river Ganges was brought from the solar system, and Akash Ganga, from the sky the Ganges was brought. The other point which is written in the book, it is that the river of light. Okay, it's also quite interesting. So what is a galaxy? It's a huge system of billions of stars and clouds of dust and gases. There are millions of such galaxies that make up the universe, right? Now let's move to second chapter, that is latitudes and longitudes. Now it is difficult to describe the location of a point on a sphere like the Earth. Now the question arises as to how to locate a place on it. We need certain system, right? Now the system developed are a set of standards. The first are the equator, right? Equators are the parallel lines. What is equator? It's an imaginary line running on the globe, divides the globe into two parts. The line is known as the equator, as it's shown. It's the standard, right? The northern half of the earth is known as the northern hemisphere, and the southern half is known as the southern hemisphere. They are both equal halves. All parallel circles from the equator up to the poles are called the parallels of the latitudes. The latitudes are measured in the degrees, right? The equator represents the 0 degree latitude, since the distance from the equator to the either pole is 1/4 of circle around the earth. Okay, so from this is here the equator, and from this point to the north pole it covers 1/4, 25% of the circle, and 25% of the circle is 25% of 360 degrees, which is 90 degree, right? Thus 90 degree is what we term as north pole, and 75% of this the point from the equator is roughly 270 degree. 270 degree can also be written as 90 degree south, and hence it is known as the south pole, which is the mirror image of the north pole, right? So this is how we learned what is equator, and how do we measure the latitude aspect of any point using the latitudes. Latitudes are parallel to each other, as we studied, and as we move from away from the equator towards pole, the size of the latitudes, the circle, it reduces. As far as the second aspect is concerned, we can also measure the latitudes. One we know is by the GPS, right? One we know is by other methods of mapping. The other is by measuring the angle of the pole star from your place. We can know the latitude of your place because the pole star is directly above the axis. The pole star is directly above the axis. Here is the axis. The pole star is also here, directly above, and because of it's very far away from the earth, all it seems as if pole star is the Polaris star is the light falls parallel, right? And if you measure the angle using sextant from the horizon, which the Sylvester Stallone in the movie, when he was trying to break away from the prison and he was trying to find the latitude of the ship, he also used the same methodology, right? Now there are some very important latitudes to remember. First is 0 degree, known as the equator. Second is 23.5 degree, known as the Tropic of Cancer in north and Tropic of Capricorn in south. The third is 66.5 degree, known as the Arctic Circle in north, and 66 degree half south is known as the Antarctic Circle in the south. And finally we have 90 degree north, which is known as North Pole, and 90 degree south, which is known as the South Pole. Now the areas between them have a very characteristic feature, because from 23 degree half north to 23 degree half south, the reason why it's known as the tropics is because the sun turn here, and because of the sun turning, the midday sun is exactly overhead at least once a year on all the latitudes in between the Tropic of Cancer and the Tropic of Cancer, and hence they receive the maximum sunlight among all the regions, and hence they are known as the torrid zone, right? Above 23 degree half north, 23 degree half south, the midday sun never shines overhead on any latitude beyond the Tropic of Cancer and Tropic of Cancer, as I already told, and hence they have a moderate temperature, and hence known as the temperate zones. And areas lying between the Arctic Circle and the North Pole in the northern hemisphere and Antarctic Circle and South Pole in the southern hemisphere are very cold. It is because the sun doesn't rise above much the horizon. Its rays are always slanting and provide less heat. They are therefore called the frigid zones. Okay. Next we move to what is a longitude. To fix the position of a place, right, as far as north south is concerned, we are okay with the latitude, but if east and west is considered, we need a second set of standards, which is provided by the longitudes. The difference between longitudes and latitudes are the latitudes, their size was decreasing, but not the longitudes. The longitudes, as we move away from the equator, the distance between the longitudes, they decrease, but not the size of the longitudes. Longitudes in by their meaning means the line joining the north to the south, which means meridian. Okay, so meridian is a line joining from north to south or vice versa. Okay, now each degree is further divided into minutes and minutes into seconds. These are the semicircles, and the distance between them decreases steadily, as I've already told. Now, unlike the parallels of latitudes, all meridians are equal in length, and this is where the problem begins. Because the longest circle is known as the longest latitude is known as the equator, but there is nothing like longest meridian, right? And hence we had to choose, all the countries had to come up with a single meridian, right? And they came with the meridian which passes through Greenwich, where the British Royal Observatory is located. And this meridian is called the prime meridian, or Greenwich mean time, Greenwich mean meridian, right? East is all eastward of Greenwich is known as the eastern hemisphere, and vice versa. And so this is where the London is located, somewhat here, and the east is India and the west is United States, and so on and so forth. So this is the second picture. Here is England. Here is our India, lovely India. Here is where the Greenwich meridian passes, and this is 0 degree. All the points, the France and then parts of Algeria all have 0 degree time. Now let's move to longitude and time. The best means of measuring time is by movement of the earth, the moon, and the planet. The sun regularly rises and sets every day, and naturally it is the best timekeeper throughout the world. Now, in order to measure local time, just at any place, watch can be adjusted to read 12 o'clock when the sun is at the highest point at the sky, and it is at midday. This time is shown by such a watch will give a local time of that place, right? Uh, the east of Greenwich will be ahead of Greenwich time, and those of the west will be behind it. The rate of difference can be calculated as follows. The Earth rotates 360 in 24 hours, 15 degree in 1 hour, and 1 degree in 4 minutes. Thus, when it is 12 noon at Greenwich, the time at 15 degree east of Greenwich will be 15 degree, right? So 1 hour, yeah, 1 hour. 1 hour ahead of Greenwich means 1 p.m. And 15 degree west of Greenwich would be 11 a.m., right? And yeah, similarly, 180 degree ahead east of Greenwich would be, 12 at the night, midnight, right? Yeah. Now, the reason is, why do we have standard time? The reason why we have standard time is it would be very difficult to prepare timetable for trains. And, if you see 68 and 97, take it as 98, almost 30 degree difference, and 30 degree corresponds, 15 degree corresponds to 1 hour, and 30 degree corresponds to roughly 2 hours. So 2 hours difference is lots of difference. Already the country is divided on the various lines of language and so on and so forth. We can't give a further room for division of the country on any other aspect, right? So what we have chosen as our standard time, standard meridian, is 82 degree 30 minutes, and that corresponds to roughly 5.5 hours from London time, the Greenwich time, right? So that's all. Thank you. Welcome back, guys, for the motion of the Earth, chapter 3. Let's start. Now, we see primarily the Earth moves in two ways. First is on its own axis and around the sun. On its own axis, it's known as rotation. Around the sun, it's known as revolution. Now, if you see the orbital plane, that is the plane of Earth with that of sun, the Earth is tilted around 66.5 degree from the orbital plane, right? And Earth receives light from the sun, and the circle of light which forms on the Earth is known as the circle of illumination, right? Now, this circle doesn't coincide with the axis, as you see in figure, right? It doesn't coincide with the axis, because the axis, it's tilted, right? It may coincide, but it doesn't coincide always. The Earth takes about 24 hours to complete one rotation around its axis, and the period of rotation is known as the Earth day, right? And this is the daily motion of the Earth, as we have already discussed things. Now let's see what are the new things which was new probably for you, and it was definitely new for me. The first thing which was new for me, which I learned from this chapter, was that the leap year. The formation of leap year, I came to know that the Earth revolves and comes back to the same position after 365 days 6 hours, and when it's accumulated over 4 years, it becomes 365 days 6 cross 4. That becomes 366 days and the end of 4th year, right? To accumulate all those, we add a 1 day more to February to become to make it 29th day, right? 29th Feb. So this is leap year. So that was learning number 1, right? As it is clearly written here, all these, right? Leap year, right? Okay. The second learning was about why, when there is summer in north, why isn't there summer also in south? By the term south, I mean southern hemisphere, right? And the reason is because of the tilt, also because uh, when the north pole tilts towards sun, the circle of illumination covers more part of northern hemisphere, leading to the summer there, causing the nights to be short and days to be long, so much so that the longest day is on 21st March and the shortest night is on the very same day. Excuse me, 21st June, right? 2106. Now, the same vice versa happens with the when the the south pole tilts towards sun, leading to the summer in south, the days getting long, so much so that on almost 6 months after 21st June, that is on 22nd December, it is the longest day in the uh, you know southern hemisphere, and shortest night there, right? So when it is summer solstice in north, and winter solstice in south, vice versa. When it is winter in north, it is known as winter solstice, and when it is summer in north, and it's known as summer solstice, right? So that was the learning number 2. The learning number 3 was that what is the difference? Why do we have, uh, you know, uh, a kind of 6 month daylight in northern hemisphere during summer solstice? And the reason is again the tilt. The reason is tilt because here you can see the circle of illumination covers complete north pole, right? And this is the reason why the northern part, the frigid zone, has 6 months of daylight, and the same is for the south pole during winter solstice, right? The fourth learning is, and this takes imagination, the case of why when there is spring, then there is autumn. Why not the same case like summer and winter? And this is because the axis of the earth is parallel, it is not inclined to the sun, and this causes spring and autumn. By the term autumn, I mean it is kind of winter is coming, right? So here you can see the summer in the southern hemisphere, and then since the area of illumination has decreased in the south, right, it is caused in winter, and this is autumn. And since the area of illumination has increased in the north, it's caused summer, right? So this is when spring in the north, summer in the autumn in the southern hemisphere, and vice versa. So the days are equal for both the north and the south, and hence it's termed as equinox, right? Uh, Important fact, another important fact, it's clear that Earth is growing around the Sun in an elliptical orbit, right? So these were the really four very. And finally, one funny fact is that that the Australians, they celebrate winter. They celebrate not the winter. They celebrate the Christmas during the summers, right? 26th December, 25th December they celebrate, or 28th December they celebrate Christmas during the summer. I wonder how does the, you know, what's the culture there? I'm wondering, do they keep the Christmas tree? How the things going there? Because it never came to my mind. So that was the fifth, the five superb learnings of this chapter, starting from the leap year. The second was the changing of the seasons. Third was the, you know, why does there is all 6 months daylight in the northern, in North Pole in during summer solstice, the cause of autumn and spring, right? Just a bit of visualization. And finally, Australians celebrating Christmas during summers. Oh my god. That was a fun fact. All right, that's all. Thank you. And here we start with the fourth chapter, that is maps. What is a map? Map is a representation of, or a drawing of the Earth's surface, or a part of it's drawn on a flat surface according to scale. The problem with the globe is that globe, you know, but when we want to study a globe as a whole, then it's beneficial, right? Moreover, the globe, it's not flattened. It's not always possible to flatten globe completely. Because globe is a globe. There will be problems when you try to flatten. When maps are put together, it's called an atlas. That was a new thing for me, right? What is an atlas, right? Maps put together, we get an atlas. There are three kinds of map: physical map, political map, and thematic map. Physical maps, the map showing the natural features of the earth, such as the mountains, plateaus, plains. Political maps, cities, towns, villages, borders, etc. Thematic maps, specific, like forest, road, rivers. These are thematic maps. Three important components of maps are distance, direction, and symbol. Now, a very important part we'll be learning here in distance, which many people confuse, right? You know, the objective of map is to reduce the scale. What is the scale? Scale is the ratio between the actual distance on the ground divided or to the distance shown on the map. Okay? So, what is exactly a small scale map and large scale map? It's clearly written. It's based on the details. A large scale map has a larger details, right? So it goes, when a large area like continents or countries are to be shown on a paper, then we use small scale. For example, 5 centimeter on map shows 500 kilometers. The ground, it is called small scale map. And when a small area like your village or town is to be shown on a paper, then we use large scale, that is 5 centimeter on the map shows 500 meters on your ground. So large scale shows larger details. So that is how, that is the trick to remember. Okay. Then is the direction. Important point to again learn here. That was the third point to learn. What are the cardinal points? The cardinal points are the north, south, east, and west. These are known as the cardinal points. Next is the symbols. You know, the internationally accepted symbols we also call is conventional symbol. It is the railways are like these, the metalled road is like the continuous two parallel lines, the unmetalled are these, the dotted parallel lines. Rivers, well, tanks, canal, bridges, all are written here. Temple is this, church is this, mosque is this, and chhatri is this, right? So post office is PO, post and telegraph office is PTO, and police station is PS. Settlement is this, and the graveyard are these. The trees are like this, and the grass is the green. Okay, so this is the accepted norm. Now, what is a sketch? Sketch is a drawing mainly based on memory and spot observation or not to scale. For example, if you want to go to your friend's house and you are asking a person what is the direction, he'll draw on a paper. Okay, you take turn left, then you take turn right, then there will become a big building, then take turn, then take U-turn, so on and so forth. So that is just from his memory. That is a sketch. What is a plan? Plan is a drawing of a small area on a large scale. A large scale map gives a lots of information, right? For example, here you see it gives lots of information, but here are the buildings of temple. You can't find what is the dimension of the a room, okay, of suppose the room. What is the size of the room? You can't find here, okay, and hence again I'll say plan is a drawing of a small area on a large scale. A large scale map gives lots of information, but there are certain things which we may sometimes want to know. For example, the length and breadth of the room, which can't be shown on a map. At that time we can refer drawing drawn to scale called a plan. So that was all. Thank you.